All right, this is a recap of yesterday. Yesterday we started talking about arithmetic sequences. We defined them and we looked for whether we had an arithmetic sequence, and then we understood the difference between the two recursive and explicit formulas. We looked at the common difference, and then we started playing around with these formulas. So let's just review really quick. Okay, there's the two formulas. The recursive formula says, we're going to state the first term, the initial condition, and then for the recursive formula, you will only use this one if you want to generate the next term in the sequence. So what you do is you take the previous term and you add the common difference. Okay? Whereas the explicit formula is nice because you can find any term in the sequence. And how you do that is a sub n, that little n value, that subscript, that is the term you're looking for. So if you want to find the 100th term, you would do a sub 100 is equal to, it's the first term plus, this n value is related to that n right there. So it's 100 minus 1 times the common difference. Okay? So the first thing we did, just really quick review. Yesterday, we wanted to determine whether or not a sequence was arithmetic. We had to look at what? Whether or not we had a common difference. If there was a common difference, a first common difference, it was. So A was, because we were adding 3 on that one, and B was not. Why was B not? Because we were not consistent with our first difference. And then we did this one. This was not arithmetic because we were adding 2, then adding 4, then adding 8. But this one was. We were adding 4, adding 4, adding 4, adding 4. Okay?
Is the n like this 4, you put the 4 in there, like the
N?
sequence? Yeah.
The n value is the number you're looking for. So let's talk about this really quick. So we've got this pattern going on. We have 1, 5, 9, 13, 17, etc. This is the first term, so we call it a sub 1. This is your second term. This is your third term, and your fourth term, and your fifth term, and your sixth term. So if we want to write a recursive formula, this is how you do it. You're going to state the first term, and in the first term happens to be 1. Not because this is a 1, it is a 1 here. Now to find the next term, or any term in the sequence, we use this n minus 1. That means if you're looking for, if I want to say the 6th term, if I call this the 6th term, I'm going to write it underneath here. 6th term, what is 6 minus 1? What is 6 minus 1? 5. So you're really looking at the 5th term, which is what? 17. And you're going to add the common difference. Well, what is the common difference? How are you going from 1 to 5 and 5 to 9 and 9 to... You're adding 4. So this is your recursive formula right here, which is you're going to take the previous term, which is 17, and you would add 4 to it. What would be the next term? 21. So if someone came up to you and said, hey, given this sequence, what's the 100th term? How would you find the 100th term? You would have to know the 99th term, the one before it, and then you'd have to add 4 to it. The recursive formula goes in order. You go one at a time.
I get the recursive formula. I get the other one.
You get the recursive or you don't get the
I don't.
recursive?
I get the, what they split, this one, I don't know what to do. I get that one.
Okay, recursive is just saying, once you find the pattern, you take the one prior and you get the next one. It's one at a time. You take this terminology means whatever one you're looking for, you take the one n minus 1, this means the one prior, and you're gonna add the common difference. That's all that means. So if you want the 6th term, you take the prior one, which is the 5th term, and you add 4. That's all that means.
So you don't times anything? Is that
No
different thing?
timesing. It's you're just adding one at a time. To find the 7th term, what are you gonna do? You're gonna take the 6th term, and you're gonna add 4. What do you get? Add 4. Add 4 to this. To get the 8th term, what are you gonna do?
Add 4.
Add 4.
So it's not a formula, you just doing a pattern basically?
Yeah, you're just doing the pattern.
Oh, I thought it was like a formula you plug in.
Well, it is a formula, but this is how you,
I don't get how to put like the formula, like I get how to do the problem, I just don't know how to use it.
Being able to do the problem is essentially being able to do the formula. All you're doing is adding the last number in the sequence, and then adding the common difference. So I know the language seems confusing because of the a sub n equal. That part's just saying, take the last term and add the common difference. And that's really all it is. It's just different, it's just the math language part is what's tripping you up.
this just means the value that you're looking for, go back 1. Go to the term you're looking for, go back 1. Go back 1. So if you're looking for the 8th term, go to the 7th term, use that one, and then take and add the common difference to that term.
Couldn't you just add 4?
Yeah, just
Okay,
add 4, that's all you're doing.
And you guys have been doing this for a long time. There just hasn't been the math language
Right.
that's been put to it, and that's all we're teaching you really right now. You guys have been filling in patterns on your MEET test since the 2nd grade, but the actual math language part, that's what you're learning.
You're being taught the formula. So when you see this on a test, you need to interpret this. It's all interpretation. Can you interpret this? Yes. When I threw this 1, 5, 9, 13, 17, and I said find the next term, you guys all knew add 4 to the next term. But the minute I put this notation here, it threw you off. But that's one of the objectives, is you have to know what this means. And not only that, you have to know that this means, this is the recursive. The recursive formula is you're finding the next term in the sequence. And you have to know that this is not a good formula for if you were going to go from the 8th term to the 100th term. Why and why? Please pay attention.
So,
Why is this recursive formula not a good choice for finding the 100th term when you know the 8th term? Why?
because you'd have to add them all up, it would take too long.
You have to know the 99th term. You'd have to go plus 4, plus 4, plus 4, plus 4, plus 4, plus 4. So we want to scrap this formula. Is it a bad formula? No, it's just not the right formula for this situation. If I say find the next term in the sequence, you want this. It's easy to add 4 to the next one. Or I might say find the 10th term,
You can do that, yeah, you can just do it a couple
okay?
times.
So if I say find the 10th term, you're gonna add 4, right? Easy? Easy, easy, easy? Okay, so now, if I say find the 100th term in this problem, well then you gotta go to this formula, the explicit. And that's what that's one of your objectives. And this is what I would recommend highly that you do. Write this formula. Write this formula down. A sub n is equal to a sub 1 plus n minus 1 common differences. So, which term am I asking you to find? Which term? The 100th term. What is it?
We don't know.
100, we don't know what it is. But I do know what my first term in the sequence is. It is 1. Now, the n value that I'm talking about, yes,
Which one are you doing then?
I'm just answering this B on the
B
example.
up here,
Uh-huh.
but it doesn't say to one.
I know, he just asked a question about, he said, D'Angelo had asked a question earlier.
Oh.
Whoops, it's n minus 1. N minus 1. So this 100, everybody look at these two subscripts right here. This and this. Can you tell me the relationship between here and here? What operation are you doing here?
100 minus 1, right?
You're taking these two numbers and you're, what are you doing them? So you're doing subtraction. So it's 100 minus 1 or
99.
99. And what is the pattern doing?
4.
It's going up by 4. The common difference is 4.
So it's just 99 times 4.
So it's 99 times 4, and then add 1. So your 100th term is, help me out. What's 100? What's 99 times 4?
396.
397? There's your 100th term. Okay? So, let's look at this next problem. And see if you can try this one. I'm giving you two terms in a sequence, 6 and 11. You are responsible, and I'm telling you that it's arithmetic. Now this is kind of sketchy because technically they're telling you that it's arithmetic. Really, you need more than 2 terms to make sure that it's arithmetic. But the fact that it says it's arithmetic, we're going to say it's arithmetic. So there is going to be a pattern. There is going to be a common difference. Okay. So you are going to be, the first objective is, can you give me a formula for this arithmetic sequence, both recursive and explicit? Can everyone do this? So, Lauren, can you do it?
Well, A1 is 6 and D is 5.
Okay. So the recursive formula, you have to state the first term. If you don't, this formula doesn't make any sense. There has to be a starting point. And then instead of this D value, you're going to write 5. So that's it. It's actually this and this. That's your recursive formula. Nothing fancy about that. Michaela?
What happens if you don't have, like, the D value?
You have to. You're gonna find it, and I'm gonna show you different ways to find it. You will have it. I'm gonna show you different ways to find it. Okay, how about the next one? How would you write this one out? A sub n, this is just a formula. What's the first term? 6. Now, we don't know, this is just a generic formula, and D is 5. Some people will leave the formula like this. You could simplify it. How would you simplify this? You would distribute. So 5n minus 5. And then if you wanted to simplify it and write 5n plus 1, there's your equation. Does it look like anything familiar that we've worked on in the past? If I change this n to an x,
Just,
does that 5 ring a bell?
Where does the 6 go? Where does the 6 go?
Well, we just simplified after, so.
I
six
added
minus
these two
five.
together.
Oh, okay. Oh,
So n still represents the term you're looking for. So if I said, hey, find the 100th term in the sequence, because it says, what is the 100th term? All you do is do 5 times 100. So A 100 would be 5 times 100. Sorry, I'm running out of room. Which is 500 plus 1 is 501. I'm going to write it better for you. Write it here.
so this for explicit.
Mm-hmm.
So you want it like minus the 100 by 1? You know what I'm saying?
Hmm?
You want it minus
If
the
if she
100.
plugged it in prior to simplifying, then yeah, she would.
If I put it here, it'd be 100 minus 1 is 99.
Yeah.
99 times 5 plus 6 is still going to give you 501.
Oh,
You're going to get the same answer.
okay.
But now, do you see what this is right here? I want to see if you see the relationship. What's this 5 right here? It's your rate of change. It's your slope. Because Michaela told us yesterday that these are linear. So to go from one to another, it's constant, it's linear. That's your rate. So your D value is like your slope.
Now, what happens if you don't do it that way?
Huh?
What happens if you don't do it that way?
You don't have to do it this way. You mean simplifying it?
Like, because I put 100 in for n.
Uh-huh, it's the same thing. We just said that. Right here? You did it right here?
Yes.
It's the same thing. We just said that. 100 minus 1 is 99. 99 times 5 is whatever, and then add 5, you're still going to get 501.
Yeah.
It's the same thing. It's the order that you did your math. It's the same thing, Michaela.
I know.
It's the same thing. It's the connection that this is linear. It's a linear equation. This 5, if you were to graph this, this is a straight line. This 5 is your rate of change. You're going to see that in a minute. Okay, look at this B. What happens when you don't have, I don't know what this pattern is. What am I going to do? Okay, so now I have to figure out a way to find these two missing terms. So I'm going to play around with this formula. I'm going to use this 100. I always start out writing this formula down. I'm going to use this 100 as which one of these? Which one of these 4 things do you think?
A sub 1?
Yes. 100 would be my A sub 1. Definitely. What don't we know? What's our unknown? The D value. Excellent. So this is a sub 1, this is a sub 2, this is a sub 3, and this is a sub 4. I'm going to say it again. A sub 1, a sub 2, a sub 3, and a sub 4. This is all I have. That's all they gave me. So does anyone think we can mess around with these 4 numbers? I need n, and I need a sub n. What? Anyone have an idea? Think.
What is B2?
N be 2.
Because you're trying to find the second and.
But I need a number. I only have I know these are my only known things.
B2 is 1.
Somebody say it.
82 minus 1.
I'm going to put my 82 here.
Would be 9.
82 goes here. That's my 4th term. And then what would go right here?
9.
Because it's the 4th term. This is your 4th term. Remember these subscripts? This is the 82, I'm using the 42, or the 82 here, which is the 4th term. Remember, these two are subtracted, so it would be 4 minus 1. Does that make sense? And I'm going to show you another way to do this.
But we still need D.
I know. Guess what? We're going to find it. What is 4 minus 1? Then what? Think back in 9th grade.
Where do we get 4 from?
It's the 4th term. 82 is the 4th term. That is the 4th term. 82 is the 4th term.
So 100.
Subtract 100. I'm going to show you another way. You might like it better. I showed first hour and they liked it better. What's 82 minus 100?
Negative 18.
And then what?
3D divided by 3, negative 6.
Okay, what does that tell you?
Did D hit a sequence with it?
That negative 6 is the difference.
Is the pattern. So, if negative 6 is the pattern, now we're going to do recursive. It goes 100 and then what?
94.
Uh-huh. And then what? And then what? And then what?
88.
And then what?
82.
Okay, but these are the answers that they were looking for, right? I got an easier way for you to do this. You're gonna like it better, I think. Are you ready for the easier way? Ready? Okay, does everybody understand that the first term was 100? And we don't know what the second term was, we don't know what the third term is, but the 4th term is what? 82. Right? If you treat these subscripts like they're x values, like this is an ordered pair. 1, 100. Wait, is it 100? Yeah, 1, 100. And 4, 82. So 1, 100. So the first term is 100. And the 4th term is 82. And Michaela told us something really important. She said that the relationship is linear. Do you remember? What did you learn? How to find what is this piece right here? 1, 100. 4, 82. What is this? Remember the slope formula? If you guys don't remember the slope formula, No one's graduating.
I remember doing it.
No one's
as
getting their diploma.
Y equals Y equals
y2 minus
mx plus
y1
b,
over x2 minus x1.
or, no?
Mr. Duke, they don't remember how to find the slope.
Isn't it y equals mx plus b?
I'm quitting.
It's like X, one.
I did hear someone say it, but
X2 minus x1 over y2 minus.
You subtract, these are your y values, these are your x values. 100 minus 82 over 1 minus 4. In ninth grade, we do the slide. Michaela, remember we did the slide, ninth grade? Come on, you remember, you were sat right there 4 years ago. We did the slide. Slide, come on, slide. 100 minus 82 over 1 minus 4, you slide.
Still right.
What is 100 minus 82?
18.
What's 1 minus 4?
-3.
What's 18 over negative 3?
-6.
-6.
What's that number?
D.
It's your common difference. So what do you do with that number?
And that seemed way faster to solve than
Oh,
what you
yeah,
was
you should have
doing.
just taught us that first.
Yeah, we're
I should have showed you this first.
Yeah.
Yeah.
My gosh. Well, I wanted you to see both ways. I want you to see where it fits in.
Can you go back to it so I can write it down?
I sure can. As long as you know that it's arithmetic, that little, you gotta know, that's the first term. That first term is your x value, the 100 is your y, these are your y values, you guys. These are your y values, and the subscript is your x value, so treat it like an ordered pair. So 100, 482. And then do your change of y, so it's the difference of these, that's your y, remember these are your y values, over the difference of the terms. Does that make sense? That's your d value. Now be careful, because sometimes the numbers go up, sometimes they go down. Got it? Okay, so let's see how smart you are. Try number 2. Tell me what the 46th term is. 3, 5, 7, yada, yada, yada. Give me the 46th term. Quickly, who can tell me the 46th term?
92.
And how did you get that?
Multiplied 46 by 2 because that's the common difference.
Wait, did you use the explicit formula?
No, I just multiplied
Why not?
46 times 2.
What's the common difference?
2.
What's the first term?
3.
What'd you get for an answer?
92.
Nope.
94. 93.
93. The 46th term is 93. You take the first term in the sequence, which is 3, and you're going to add. You're looking for the 46th term, that's your n value, minus 1, so you're going to take the 45th term, multiply by your common difference is 2, so 45 times 2 is 90, 90 plus 3 is 93. Next one. Here you go, you get to practice that one I just showed you. Give me the second and third term. Now, you want to use my little shortcut? See if how good you are at it. I'll zoom. Travis, are we still on the screen?
Yep. That was easy. So how, do you get the 4 because there's 4 things?
Yes. This is the first term. So the first term is 80,
Mm-hmm.
and the fourth term is 125. And because it's arithmetic, our rate of change is linear, and I get to use this formula.
So it's going up.
It's going up. How do I know it's going up? Well,
It's
from
not an
80 to
negative.
125, it sure is going up. Always make sure that it makes sense. You always want to look at your answer and say, hey, does this make sense? It's going up by 15, and yeah, it sure does make sense. Okay, what do you think on those? Good? Better? All right. Read what's in the next box. Arithmetic mean. It's a good thing we just did a chapter on mean. What does mean mean?
Average.
Average. So, if I gave you 3 numbers, and two you knew, like this right here, if I wanted you to find the average of 2 numbers, what would you do? This is really easy. Add them up and divide by 2. How easy is that? Add the 2 numbers and divide by 2. So using that idea, that's how you find the average. That's going to give you the missing term. So if there is one missing term between 2 numbers, use the average. So go ahead, tell me what the missing term is.
37.
Okay, how did you get that? What'd you get?
37.
Okay, now I have a question for you. Did anyone get a different answer when you typed it on your calculator?
No.
Because some people do this. Simple mistake. They'll do 15 plus 59 divided by 2. Watch this. 15 on your calculator.
Yeah, it gives you 885
Whoops.
over 2.
You put 50.
15 plus 59, if you type this in your calculator like that, what your calculator will
Just
do
divide.
is
first.
it's going to divide these 2 and then add 15. So how do you fix this problem on your calculator?
1559 first.
You have to put them in parentheses. the 15,
Okay, you could do a couple things. There's actually 3 things you could do.
I would just separate it.
You could put these in parentheses, that's one option. You could type 15 plus 59, hit enter,
And then hit the.
and then hit divide. Or you could type it like this on your Inspire with the bar, and so you've got some options. But please, you guys, if you type it in like I had it, the way I had it incorrectly, you're going to get a decimal answer. Okay, try this next one. If you had the 9th and the 11th term, and we said the 9th term is 132, so that's your 9th term. We don't know the 10th term, and we know the 11th term is, I can't read that.
98.
98. How would you figure out this term right here? What would you do?
132 plus 98.
You would add these 2 up and divide by 2. What would you get?
115.
What do you get?
115.
115. Okay? So you would add these 2 up and divide by 2. Right? So your middle term is 115. Questions? Now, I have a question for you. I want you to read this letter B. Check this out. If you were given 2 terms in a row, the 5th and the 6th, the 5th and the 6th term, and you were given the mean, how could you find the 7th term? So let's use this example right here. If you were given this term and this term, but not this one, and you were given this, what could you do?
Add the common difference to the sixth term. Add the common difference to the sixth term.
So if someone gave you this term and this term, but not this one, what would you do?
Oh, what? Isn't the mean and then that, like the 10th term, the same thing?
If you knew these two terms,
The 9th and the 10th term, you're looking for the 11th.
and you
term.
need this, and you were given this, so you know this one, you know this one, and you need this term, but you have that. So look at these three things. You have this,
Would you just subtract them and then?
what do you do with these two?
opposite. You times the mean by 2.
Yep, if you take your mean and multiply it and then subtract it, you can figure out what that term is. So if you multiplied these two and subtracted this, then you can figure out what that missing term is.
Might be easier.
You mean
to
subtracting
see if you actually
132?
put the variable, like, the unknown x, and like 132 plus x.
You said it wrong, I think, Miss Elliott.
This is your mean.
So then, for that example, it'd be 132 plus y equals, or divided by 2 equals 115, and actually have one.
So if you cross multiply these two and then subtract,
You gotta subtract it by the x though.
yes, you're gonna subtract that. But you're given, so you have these three values. You've got, you have the 132, you have the 115, actually, let me put these numbers in. Let me put these numbers in, 115, sorry, this isn't the mean. The mean is,
2/3.
we know the mean. We know the mean, but they didn't give it to us, did they?
No, they didn't.
So what you would do is you would multiply the mean
By 2
times 2,
minus 132.
and then you would subtract the 132.
So it's 115 times 2 minus
So-
132.
Yes. You would multiply the mean, whatever the mean is, you would multiply these two together, and then you would subtract it. And that's how you would find, that middle term.
Do you multiply by, you take the 115.
That's your middle term
you
right
times it
there.
by the 2, and then subtract it by the
So if you're given the mean right here, so here's, this is kind of confusing. So in this problem, you found, you had to find that middle term. Okay, so you added these up and divided by 2 to get that middle term. If you don't know that middle term, what you would do, and you know this mean, so now you would multiply these two together and then subtract, and that would give you your,
Wait, where do you get x though? Like, if
I'm
you
just
were
saying
to-
if you know the ninth and the two terms, the fifth and the sixth term. The fifth and the sixth, this would be the fifth. Go ahead, show 'em.
Okay,
So
so,
what would be the,
Use that.
would it be?
alright, so, if you actually plug in our values, we knew the 9th term, but we didn't know the 10th term. And then, wait.
I know, it's hard to explain.
Am I saying that right? So if you have 132 plus y divided by 2, we didn't know the outside term. So we didn't know the 11th term. Y is the 11th term. Okay, if you write it out like this, and then plug in 115, because we knew the 10th term, you just multiply by 2, and then subtract.
Yeah.
So 115 times 2 be 230 minus.
Because you don't have any numbers.
I don't get how you're figuring B out when they don't give you any numbers. Are you supposed to use the numbers because they're using the previous problem?
No, we just use
We just use
the
numbers to show
previous
it.
problem.
Yeah, we just use the previous
So
problem.
on the test, it's not
It's
gonna
not that
have that
hard.
with the no numbers.
No, this was just getting you to think deeper into, if they gave you two numbers together, and they gave you the average, and they said, find the next term, you use that, find the next term, you could cross multiply,
So you were just using those numbers for that one?
yeah.
It's a long.
You can, I think that's it. Oh, no, we have the story problem. This is easy. Now this is gonna be a piece of cake. The story problem's gonna be a piece of cake. So, why do we need to know this? We have a sports arena. And in a sports arena, you know that the seats are not straight. They can't be. They have to be tapered, right? So the lower level, there is, in the very first level, we started this yesterday. The very first row, there's 14 seats. And then what's happening is it's getting wider and wider, and then the very top, you have the nosebleed seats. So the first row has 14 seats and the second row has 16, and it keeps, we're pretending like it's arithmetic. So in other words, the pattern is increasing by 2. They just want to know how many seats are in row 13. Now, I wouldn't do a recursive. I would not add 2 to each row. I'm going to jump into the explicit formula. So I want to know in row what? 13, how many seats are there? So what's my formula? You take the number of seats in row 1, and you are going to add, you want to know the number, the row that you're looking for, minus 1. So in other words, in row 12, this is row 12, times, what's that pattern? What's it doing? It's going up by 2. So help me out. How many seats are in row 13? How many seats are in row 1?
14 plus.
So 13 minus 1, which is 12. What's 12 times 2?
24.
So 24
Plus 14.
plus 14 is,
38.
there are 38 seats in row 13. What if I wanted to know how many seats are in row 100? What are you going to do?
14 plus 100 minus 1 times 2.
2 times 100 minus 2.
Eventually, I'm going to ask you to add up how many seats are in this entire stadium. That's what you're going to have to do. I'm going to ask you to add up, this is what you're going to have to do. Add up how many seats are in row 1. If I asked you to add up to row 13, are you going to sit there and run the aisle and say 1, 2, 3, 4, 5?
Yes.
No. What if I say there's 130 rows? You're going to sit there and add up all those seats? No.
Calculate.
So guess what? If you can't do this, you're not going to be able to sum up all the seats in the stadium. So one day you might be working for the palace, or you might be, that's a job out there. So this is a real world example. And if you show me how to do number 4, I'll be happy. Number of seats in the first 16 rows in a curved section of another arena form an arithmetic sequence. It's important to know that. There's 20 seats in row 1. How many are in row 2?
23.
So how many are in row 16?
65.
How'd you get that?
20 plus, and then in parentheses, 16 minus 1 times 3.
Wait, how'd you get A? Oh, you're looking for the 60.
You gotta read this. In row 1, it's 20. In row 2, it's 23. So n minus 1. I'm looking for the 16th row, so I'm going to do 16 minus 1. So what row am I looking at, really? The 15th row, and the common difference is 3. So what is 15 times 3?
60.
What is that?
45.
What's 45 plus, what are the number of seats in row 1? So there are 65 seats in row 16. And you should label. The rest is your homework. This is all on YouTube. Yep.